Alright, it's time for the solutions for the average rate of change paper, which the regular classes got. And if you look through here, this top part kind of explains what average rate of change is. And in summary, it is slope. And slope is just the change in y's over the change in x's. Or in other words, rise over the run. How far you go up and down versus how far you go to the right and or left. Okay, so that's what's going on in this. You're just calculating slope. And when you get to this first section here, even though it doesn't... Oh, it does label it. Okay, that's nice. It just says that runner A is the dashed line. It just so happens that they didn't draw a dashed line. And so, notice that it is that lower one. And then we're answering the questions. Which runner has a faster average speed for the first 9 seconds? So if you start here at 0, 0. At time 0, they're at meter 0. And then after 9 seconds, they're actually at the same distance, which is 120. So if you look at their change in y, and you put that over the change in x, it's just going to be 120 over 9. So they actually have the same average speed. And so that's what we're going to put for this first. And that brings us to the next question. Which runner had a faster average speed between 9 and 20 seconds? So at 9 seconds there, they start at the same point, but after another 11 seconds, when they get to 20, there's a disparity between them. There's runner B and there's runner A. And runner A didn't go up as far, so he had a lower average speed. And so runner B would be our winner here. Runner B would be the one that has a faster average speed there. And that brings us to the next question, which is here actually. We already answered these first two. Which runner has a faster average speed for 20 to 31 seconds? Well, here's 20, and here's the 31 second. So runner B had to go up that much and over that much, and runner A had to go up farther and went right the same amount. So runner A had a greater increase in the same side-to-side motion. So runner A would be the one that had the faster average because he had to go farther to get caught up. And it's asking which ones had a faster average speed from 9 to 31, so from here over to here. Well, they start at the same position, they end at the same position between those times, and so they actually have the same average speed. And then that brings us to the last one. Which runner won the race? And use mathematical evidence to support your answer. Well, to get that answer, you need to look over here and realize they're running a 400-meter hurdles race, and 400 meters is right up here. And you need to figure out which one of those runners reaches that line first, and by first I mean with the least amount of time as you go from left to right. Well, as you go from left to right, notice runner A got there at about 37 seconds, and runner B didn't get there until about 50 seconds. And so runner A would be the one that won the race. And it's because of just what I said. And you can write that here for your explanation. And that brings us to the back part. What you need to do is draw a line that connects the 2 points and write the coordinates of the 2 points. Then calculate the average rate of change. So let's go over to number 1. We're going to need to draw a line that connects the 2 points. So they're actually like this. And the coordinates of this one are the coordinates 2, 5. And the ones over here is looking like 6, 5. And if you want to calculate your average rate of change, you get your difference in y's, and you put that over your difference in x's. So you do 5 minus 5 over 6 minus 2. So you can give us 0 over 4, which is just 0. So average rate of change is just 0. If you move on to 2, we need to go from negative 3 to 3, so those are the points. And if we draw that line, it's actually the same as the line that's already on there. The coordinates over here is negative 3, 3, and the coordinates over here are 3, 1. If you want the average rate of change, you do 1 minus 2, the 3. And then you need to do 3 minus -3. So I'm taking the y's, put them there, And then my x's are what are going in these spots here. Okay, so that's where all my numbers come from. And when I calculate that, I'm looking at -2, and on the bottom, it's going to be 6. And you can simplify that just to be -1/3. So that's my average rate of change. That brings me to 3. And you need to go between 0 and 2. The coordinates here are 0, 9. And the coordinates over here are 2, 1. And the line that goes between them looks like this. Like so. And if you want to get your average rate of change, you need to do the 1 minus the 9. And you put that over the 2 minus the 0. That's going to give you -8. And on the bottom is 2. So that gives me an average rate of change of just -4. And moving on to 4. You want to do it between 0 and 3, these points that are already listed there. The coordinates over here, we're looking at 0, 4. And the coordinates over here are 3, -3. You want to get your difference in y's, so you do -3 minus 4, and then 3 minus 0 to get the difference in x's. That's my rise, there's my run. It's going to give me -7 and then over 3. So that's actually my average rate of change. It doesn't simplify. It's just going to be -7/3. 5, we need to go between -3 and 1, which is this line here. The coordinates over here are -3, -5. And the coordinates over here are -1, 3. If you want to get your rise, you need to do 3 minus the -5. If you want to do the run, you get the difference in x's, -1 minus -3. When you do that, you're going to get 8. And on the bottom, you're going to get 2. Because -1 minus -3 is going to be -1 plus 3, which gives me 2. So my average rate of change is just 4. Moving on to 6. Again, we need to draw a line between our points here. Notice there are a lot of different rates of change, a lot of different slopes, but we want to get just the average. The point over here is the point -3, -3. And the point over here is the point 0, -12. So if you want to get your rise over run, you need to do -12 minus -3. And 0 minus -3. It's going to be a 3 on bottom, and then a -9 on top. And if you simplify that, you're going to get -3. And that's my average slope. You notice it goes down 3 right 1 to get to all those points there on the line. It brings us to 7. We need to go from 0, which is here, whoops, down a little bit, here, to 3, which is right here. Coordinates over here, we have 0, -4, and the coordinates over here, 3, 5. So if you want to get your rise over run, you get the rise by the difference in y's. So 5 minus -4, and then difference in x is 3 minus 0. It's going to be a 3 on bottom, a 9 on top, so we have an average rate of change of just 3. That brings me to 8. You need to go between 0 and 1, so there's my line. The point here is the point 0, -2. The point over here is the point 1, 1. If you want to get your average rate of change, you do the difference in y's, so 1 minus -2, over the difference in x's, 1 minus 0. 1 minus -2 is 3, 1 minus 0 is 1, so my average rate of change is 3. 3 show up a lot in this problem, these ones. And then on 9, we need to draw the line here that goes through those points. The coordinates for the left one here are 1, -2. And the coordinates over here is going to give us 5, -2. And that's where we're at when you get the difference in y's and put that over the difference in x's. So you do -2 minus -2, and then you got 5 minus 1. You're going to get 0 over 4, which is average rate change of 0. Just like so. And that's all our solution.